All right. I think we can begin now. Also, Sebastian, glad to see that you made it. Yeah. Jack, you want to begin?
Yeah, sure. Max, are you presenting my slides right now? Alright, cool. Go to the next one. Alright, so I'm just gonna go over the electrical board real quick with you guys. It's gonna be a little more in depth than the big presentation we had a few months ago. Alright, next one. So, this is the circuit breaker and the battery. The battery itself is the only source of power on the robot. So we only have that little box right there. And once that's out, that's out. That's why we can't put too many electrical components on the battery. And we have to make sure that we've got recent batteries because old batteries, if you guys know, have diminishing charge as they get older and older. And these types of batteries and the chemicals in them wear out very quickly. So we got to get new batteries every like maybe 1 to 2 years. And the circuit breaker here, if you notice, is very big. It's extremely foolproof as the design is very simple. It's kind of like a switch in your walls. If there's too much voltage, something inside it's going to snap and it's going to instantly end the circuit. So nothing will fry up, nothing will explode, anything like that. It can be mounted virtually anywhere because they're so simple. As long as we've got wires that are long enough and good connectors, they can go completely on other sides of the robot right next to each other. It's really whatever we want. Whatever we want. All right, next slide. So this is the PDP that stands for the power distribution panel. The power from the robot goes into those two black rods on the bottom, or the power from the battery goes into those two rods on the bottom and gets distributed to all the parts on the robot. The big red and black parts go to the motor controllers that then go to control the motors. The little slots down the middle are for tiny circuit breaking fuses that actually go into the board itself. So if there's any kind of overload that gets past the circuit breaker, the big one that I showed before, those will snap and end the circuit there. So everything is very safe on this. It's not like we're working with raw circuit boards or soldering everything together like that. Most of the stuff is pre-made and very safe, so we'll have minimal issues throughout the season. Uh, it also has a CAN bus relay point at the bottom right, that little white part with the green and yellow things. I'll go over that a bit later in the Robo Rio slide. Next slide. Now we have the VRM. This stands for Voltage Regulator Module. This regulates the power to very specific sensitive components on the robot, like the radio that'll broadcast to our computer. Radio is just a fancy way of saying Wi-Fi router. So that's how we can control the robot wirelessly in competition. It also directs power to the pneumatics control module and other things kind of like that. This can and will break very easily if it's not wired correctly. So if a wire is sticking out and it bridges a connection, this doesn't have its own internal circuit breaker. This, in a sense, is its own circuit breaker to protect the radio and the pneumatics control, stuff like that. And these are also kind of expensive if we keep adding them up. They also don't like getting wet or having any kind of moisture on them. These are very, very easy to break. So we want to kind of be careful with this. It can also be mounted anywhere, but we want to be kind of sensible where we put it. Next slide. This is the PCM that stands for Pneumatics Control Module and a general layout of the pneumatic system below it. The pneumatics control module itself controls every pneumatics component on the robot. They don't go through the power distribution panel or the voltage regulator module. They only go through this. And power for this comes from the voltage regulator module or the power distribution panel. It's really whichever one we kind of want to flop to. This also has a CAN bus relay point in the top left. That's the little white part that has the green and yellow bricks on it. Pneumatic solenoids, you can think of them as switches for air. So if we direct power to one of them, it'll either close or open a circuit, well, the circuit with the air, and there's another one. So if you look in the top right of the pneumatics board picture that I have on the bottom, that's the actual solenoid, the one that has two pipes coming from it that goes into the piston on the very, very far right. Pistons They go out, they go in, depending on where the air is put. If the air is put at the bottom of them, it'll shoot it out. If the air is put into the top, it'll reel it back in. The pressure indicators are those little dials on the top and bottom. They'll tell you how much pressure is either in the system or inside of the air tank itself. Also, with the pneumatic system, the air tanks that we put on the robot are the only air that we can use for the competition unless we want to put more air in with the compressor, which will take a lot of power from the battery. So, if we're going to do pneumatics for this season, we really want to make sure that we have enough air to do whatever we're going to use. Like, if we want to do pistons for a lot of it, we're going to have 2 or 3 air tanks. If we're only using it a little, we might want to dial it back to control the weight, stuff like that. Next slide. This is the Robo Rio. This is mostly programming's territory, but we do, as electrical, have a little bit of control with what goes on in it. It can look very complicated and very intimidating if you've never seen it before, but it's very easy to work with. The far left side, DIO, that is all analog input and has very clearly labeled, like, I think it's 0 through 9 on it. So although you can see all those pins, they look kind of disorderly. They're very set in what they do, and they're very easy to read. The far right is PWM. Those are digital inputs. Those are also clearly labeled 0 to 9, I believe. On the top left, we have the final CAN bus input. Now, the CAN bus is mostly just used by programming. It's a way of getting code to different parts of the robot for controlling power output. I'm sure Max can and will go over that with you guys later. And then at the top, we've got USBs, Ethernet, all that stuff for dealing with Wi-Fi control and different components on the robot. And at the very bottom, we have some additional analog inputs and some reset buttons. But yeah, that's it for the electrical board.
Yeah, it's pretty simple. Jack, can you elaborate more about like because a lot of people don't know like what digital input is and all that.
Yeah, sure. So analog input, you can just think of, if you guys have heard of binary with ones and zeros. One being on, zero being off, or vice versa, depending on how we want to work that. That's it. There's only 2 states. There's either on, there's off, there's nothing else. Digital can have a bunch of variable inputs. Like if we do some kind of angle measurement that has a specific number, like, I don't know, 76. Now that's not on or off, that is 76. That could be 76 out of 100, 1,000, 80 if we wanted to. So that's the real difference. The digital inputs can have multiple different states, and analog can only have on and off.
I thought it was the other way around.
No, no. Analog is just on and off. Because, I mean, analog systems, those were the first ones. Those are the simplest ones. It's like a switch. A switch produces an analog signal. You can either have on or you can either have off.
Can you try and explain like how can we get so one thing that we do is we have a lot of sensors on a robot, whether that be cameras. We do have ultrasonic sensors, although we don't use them too much.
We don't like to use the ultrasonic
Yes, we also
sensors.
have the what's it called?
Uh,
The rotation thingy.
but we don't want to use those.
No, we don't want to use those. But like for example, if you're trying to connect, let's say a camera to the whole system, where would you do it and how, etc.
For the cameras, you would put them into the USB slots at the top of the Robo Rio. There's 2 of them, and they've got 2 tiny screw holes next to them.
All right.
That's what those are for. And then there's 2 USB things. There's the 2 on the very top, and then there's a USB-A towards the left that can be used to directly connect, I believe, the computer to the Robo Rio.
All right. This last thing is, can you just give a very brief explanation of electrical safety and all that?
Yeah,
That's pretty
sure.
important.
All right. So, general electrical safety. You don't want to work with wires that are connected to the battery, even though the battery is only 12 volts. It has a ton of current. Current will be very bad if you connect both the poles together and they're near your skin. It can severely burn you. It can temporarily paralyze you. It's not fun. So if you ever have to work with active wires, which I don't think we ever would, you would have to wear rubber or latex, any kind of insulated gloves, so that if those two poles come into contact, they won't actually touch your skin, and those insulators will protect you. When we work with sharp objects like wire strippers, of course, we want to be very safe with those, either wearing thick gloves or being extremely cautious, especially wearing like safety goggles so that wire strip parts or tiny copper particles don't get into your eyes. Those are very bad. We don't want that kind of stuff. All right.
All right, yeah.
Does anybody else have any questions at all? All right. Okay.
Cool. Hell yeah.
Thank you, Chris.